Okay, good afternoon, everybody. Today we are going to have third lecture of Signals and Systems course. Any questions before I start? Okay, so I just want to finish off the things that were left unfinished last week. Let me start. So we are talking about response of linear time invariant systems. Okay? For short, we say LTI systems, linear time invariant systems. Okay, what was linear time invariant system, by the way? Who would like to remind us of that? In plain terms. Which systems are linear time invariant systems? Anybody? Well, what does it mean exactly? Okay. If you take the same input at any given moment, it will give the same response, right? It is today, whatever response it will give for the same input, it will be the same result as tomorrow. Yes. So this is the input and the output. We say that the response of the system to impulse is ht. We call it h of t. Okay? So we say that if you know the response of the system for an impulse, and you call it h of t, then you know everything about the system. What was h of t? H of t was defined as, it is 0 if t is different from 0, and an integral of, not h of t. So minus infinity to plus infinity. Okay, this is how we define Dirac delta function. An approximation of that was, I sometimes call it Dirac delta function, sometimes I call it impulse function. They all mean the same thing. I don't mean anything different. Okay? So this is t. You have delta here, and 1 over delta. This is an approximation of the impulse function, meaning when delta goes to 0, the integral of this is always 1, isn't it? The width here is, this is a rectangle. The area in this, under this curve, is always equal to 1. It is delta times 1 over delta, it's always 1. So when you take delta go to 0, area is always 1, and that the magnitude goes to infinity, but it doesn't go to infinity in an arbitrary manner. It goes to infinity such that the integral of this function is equal to 1. Okay? We use this approximation of the impulse function, and we came up with the response of a system for any input, okay, based on the impulse function. What did we say? It was yt is equal to, from minus infinity to plus infinity, h tau x t minus tau d tau. Okay? Another way to write this is h convolution x. Okay? This is what we did in detail last week. Okay. Then causality. Causality means the following. The output of the system at time t equal to 0 should not depend on any input in the future. It should depend only to the input now and in the past, right? So the causality, if it is not causal, that would mean that you would have to somehow know what are the future inputs so that you can calculate the output for now. So it should have the predictability. It has to be a predictive system. So physical systems are causal. So things depend only on the present and the past. Okay? So when you look at yt is equal to minus infinity to plus infinity, h tau x t minus tau d tau. Let me talk about now y0. What is y0? Minus infinity to plus infinity, h tau x minus tau d tau, isn't it? So t equal to, you take t equal to 0. Okay? When you look here now, you have, let's say for tau is equal to minus 1. To be able to calculate this integral, isn't it? The output at time t equal to 0 would depend on minus 100, so this becomes x 100, isn't it? Because it's x minus tau. Minus 10, it would depend on x 10. So for all these negative taus, you would need to know them and compute them here. So how do we make sure that the system does not require these things? What would be a way to eliminate the need for knowing the future inputs? Okay? If h is 0 for negative taus, okay, if h of tau is like that, ht is equal to 0 when t is negative, okay, and it is something. So what would this integral, what would happen to this integral? The lower limit of the integral would start from 0, right? Since it is 0 for negative taus, all these things, that part of integral, so that would mean for causal systems, this is equal to from 0 to infinity h tau x. Okay? Now, to be able to compute the output at t equal to 0, what do you need to know? You need to know the value of the input for negative times, right? For the past times. So what was input yesterday, today, 1 second ago, 5 hours ago? That's okay. That past already happened. So you have access to past information. So the 0, you see when, for example, 0, this is 0, x0. You know what it is now, right? As soon as you turn on the system, what is your input right now? It is x0. You know that. So after 1 second, this is x minus 1. So what was my 1 second ago? You know that. So you know all the inputs from now, and you know all the history. There is no problem about it. So we are talking about causality, okay? So if the impulse response is 0 for negative times, then the system is causal, okay? Another way, how can we write this? This is equal to, what was another way to write this? h t minus tau x tau d tau, right? So for t equal to 0, so what would that be? h minus tau x tau d tau. Okay? So this is from minus infinity to 0. Okay? So this is another way of writing the same thing. So it gives you exactly the same result. Okay? It's just a change of variable. This is for causal systems. Any question on causality? Yes? This is convolution. So if you multiply two functions, let's say you have zt equal to xt minus, that means you multiply the value of two functions for time t to obtain the value of the function zt. When you convolve them, it is like you multiply them in this time-shifted manner, and you integrate it for all tau. Okay, so it is a more complex operation, and this is how linear time invariant systems give output for an input. Okay, that's for causality. Let's say that our linear time invariant system is defined by a differential equation. Let's say this is x, this is y, dy dt plus 2yt is equal to xt, let's say, okay? X. So in this case, as we did in the first class, we had two circuits, if you remember. They had capacitors and resistors and the input as the power supply, right? So the relationship between input and output is not a proportional or something. It is defined through a differential equation like this. So, and let's say we also have input e to the, what did I take it here? So input is just e to the 3t, k e to the 3t. So there is such an input, and I would like to know how the input and output are related, right? How do we solve such a differential equation? Who took differential equation course? Who took the differential equation course? Who did not take it yet? Okay. So what you do is that it is two steps. One, you take the homogeneous part, okay? You set the right-hand side equal to 0, okay? You solve this, okay? The solution of this, you call it your homogeneous. Homogeneous, okay? Homogeneous. You find the homogeneous part, meaning satisfying the differential equation when there is no right-hand side. Of course, linear time invariant system. Okay, 2, you find a particular solution. Solution, a particular solution that satisfies 1, okay? So that is dyp dt plus 2ypt is equal to x of t. So that has to do with x of t, okay? Then third step is you say y is equal to y homogeneous plus y particular. And the fourth step is satisfy the initial conditions. Okay. So when you have a differential equation like this, what we do is that we say, let's look for a solution like this, C e to the RT, okay? Can we find the C and the R such that if we substitute this in this differential equation, it satisfies it? For what C and R, we can satisfy this. So you just take the derivative of this, y prime t is equal to CR e to the RT. Okay, substitute here, CR e to the RT plus 2C e to the RT is equal to 0. So e to the RT and C are common, so C e to the RT, R plus 2 equal to 0. When is this equation satisfied? When can you satisfy this? Of course, e to the RT is positive and non-zero for any t, right? So you can just cancel this. So when can this equation be satisfied? When c is equal to 0, is it satisfied? Okay, so is this okay? Can I take c equal to 0? Why is that? What's the problem with that? It's called a trivial solution, right? It's called trivial solution. It satisfies this, but you cannot satisfy the initial conditions. So in this differential equation, you will have initial conditions. So you have no degree of freedom left. So therefore, c equal to 0 is the trivial solution. As a matter of fact, we don't need anything for that. We could just say if you take y equal to 0, this is satisfied. So in that case, then you have to have r plus 2 equal to 0. That means r is equal to minus 2. So what do you have then? You substitute that here. Y homogeneous t is equal to c e to the minus 2t. So we found the homogeneous solution. For particular solution, for differential equations with constant coefficients, linear differential equation with constant coefficients, we find a solution, as I told you in the previous class, and it's clear from here that these linear time invariant systems, whatever goes in, will come out with phase change and magnitude change, okay? If it's a stable system. So therefore, if the input is, if x of t is k e to the 3t, you expect the y particular of t should be something like, let's say, a e to the 3t. We say that, can I find a solution like this? Can I find an a such that this will satisfy the differential equation? So what is the derivative of this? 3a e to the 3t. So you substitute here. So it is 3a e to the 3t plus 2a e to the 3t should be equal to x of t, right? It is k e to the 3t. E to the 3t is common in all of them. So you have 5a equal to k, meaning a should be equal to k over 5. So we have the particular solution then, y particular t is equal to k over 5 e to the 3t. Okay, what is then the solution? Yt is equal to y homogeneous plus y particular, which is c e to the minus 2t plus k over 5 e to the 3t. What is k here? This is given, right? This is the input. So we have no control over it. So somebody inputs into the system. C is something for us to discover. How do we discover that? We say that if y0 is equal to 0, meaning in the beginning we assume that all the capacitors and all the inductors, if it's an electrical circuit, they are in relaxed mode. There is no stored energy in the system, okay? You are just starting it. So you assume this is 0, then y0 is equal to c plus k over 5 equal to 0. Then c is equal to minus k over 5. So yt then will be equal to k over 5 e to the 3t minus e to the 2t. So this, when you look at this, this is now the response of the system, right? So when t equal to 0, it starts from 0, okay? Then it will probably go positive because this grows. And after a while, this will disappear. Okay, it will keep going up. Okay, so this is coming from the input, and this is coming from the internal modes of the system. This is the this is the internal natural response, and the particular solution is the forced response. That's the response of the system inside. So since this term is e to the minus 2t, when t grows large, this will disappear. So what will happen is that only whatever goes in will remain, and the rest will disappear. Of course, it is being scaled. It came in as k times e to the 3t. It is now divided by 5. Okay? Any question? In general, if you have let's say let's call this BM. You can have a system, this one input, one output system, in which you have the nth derivative of y, the output, depending on m derivative of the input. Okay? So this is a dynamical system. And we would analyze the behavior of this kind of systems. Again, the same approach is, you follow the same approach. You first calculate the homogeneous solution by setting the right-hand side equal to 0. Okay? You solve it. Then you find this is 1, 2, find a particular solution okay, 3, let's call it ypt. So yt is equal to y homogeneous plus y particular. And 4, satisfy the initial condition. Maybe we make a problem session, and in that problem session, we solve some examples on this, because I want to start the Fourier series today. This is what I want to tell you remaining from last week. Any question? Now, we want to talk about Fourier series. Okay. Last week, in the mathematics review, we said that if you have, so we like polynomials. Why? Why do we like polynomials rather than any function? They are easy to compute and understand, isn't it? So fundamental theorem of algebra tells us that an nth order polynomial has n roots, okay? And we can calculate value of a polynomial just using multiplication, addition, subtraction, and division. So it is very simple to compute them. So polynomial, we said, was like a0 plus a1, x minus x0, etc. an. Okay, so this kind of functions are called polynomials. We said that how can you show any function, if it's not, even if it's a polynomial or not, how can I show it as a polynomial? We said that you can do that with Taylor series. Let's say n equal from 0 to infinity an x minus x0 to the power n. And we found out that this was equal to nth derivative calculated x0 divided by n factorial x minus x0 to the n. Okay? Now, we come to the question of periodic functions. Let's say periodic, this was for any function in general. Now, let's talk about periodic functions. Periodic function means that for a given t greater than 0, you have x, f x plus t is equal to fx for all x. Okay? Of course, what is an example of this? Sine, right? So sine x satisfies this condition. So it's a periodic function. So sine x plus 2k pi is equal to sine x for all x. Okay? What is the period of this? It's 2 pi. But it is also periodic with 4 pi, isn't it? 6 pi. So it is periodic with any multiple of 2 pi. Any integer multiple of 2 pi is a period of sine x. But what is the fundamental period, which is the smallest of all these, is 2 pi, right? What is another function with periodic with 2 pi? Cosine. So it is cosine. So it is. Okay? How about cosine omega 0t? Let's plot this one. For t equal to 0, this is 1, isn't it? For t equal to 0. So for what value of t, this is pi over 2. This argument is pi over. So we just write it here, isn't it? Omega 0, let's call it t1 equal to pi over 2, which is omega 0 is equal to pi over, so t1 is equal to pi over 2 omega 0, right? So this is pi over 2 omega 0. This is equal to 0. Then for what value of t2, omega 0, t2 is equal to pi? That t2 is equal to pi over omega 0, right? So that is equal to okay. So minus okay. So what is the period of this? T. What is this? Is the period, isn't it? So it starts from -1, goes up, and comes down to the same value. It now repeats afterwards. So this is equal to t. What is this length here? 2 pi over omega 0. So that's the period of this function, right? So I can have another function. Let's say I can have something like this. Okay. T over 2. And let's say this is also periodic, isn't it? So it repeats like this. It will come down, go up. So what is the period of this again? T. So what is the fundamental frequency? It's not a cosine or sine, but it is, again, you can say that this is the fundamental frequency of this thing. Okay? So the question is this. Can I write any periodic function in terms of sines and cosines? Okay? So this function, I know sine and cosine very well, isn't it? I know how to compute it and everything, and it has some meaning for me. If I give you any other periodic function, okay, the general periodic function like this, fx plus t is equal to f of x. Can I write this as, so the question is, if f of x plus t is equal to f of x for all x, then can I write f of x is equal to some a0 plus a1 cosine omega 0 t plus a2 cosine 2 omega 0 t plus an cosine n omega 0 t, etc., and plus b1 sine omega 0 t, b2 sine 2 omega 0 t, okay. A short form of writing this is like this: a0 from k equal from 1 to infinity an cosine n omega 0 t plus k equal from 1 to infinity bn sine n omega 0 t. Okay? Can I write it in this form? So can I say this is equal to that? Okay? And what are these a0s and ans and bns? How can I determine them? Okay? The answer is yes, you can. And who invented this was Fourier, about 150 years ago, a French mathematician. Fourier discovered this. It's very nice and beautiful property. So how we do this as well? You remember in Taylor series, how did we discover these formulas? We said that let's ask f of x and the polynomial have the same value at x equal to 0. That gave us a0. Then we said let their first derivative also at x0 be equal. That gave us a1, right? We continued like that. We asked that the derivatives of both sides be equal at x0. If you remember from last week, you can watch it in the video. Now here, we do something else. It's also very smart, but we do something else. Let's say, okay, this is f of x equal to this, right? We say that let's calculate, and this is periodic. What is the length of the period? It's t, capital T, right? So it is periodic with period capital T. What does this mean? This means given any interval with length t in the x-axis, it is periodic there, meaning just take half of it, and it's going to repeat itself after after t, another t, another t, you will always have a copy of it, right? That's what it means. Does it satisfy it? By definition, this is f of x plus t is equal to f of x, right? That's the definition of it. That's how we assumed it is. How about these? Are these periodic? Of course, that's how we select them. Okay, so let's discover those. Let's say sine n omega 0 t plus t. Is this equal to sine n omega 0 t for all t? Let me just make this t and this t. I'm sorry. It doesn't matter, but it's just, there are more t's here. Is this true? So let's just expand it here. What do you have inside? Sine, what is it? N omega 0 t. N omega 0 t. And what is this? N omega 0 capital T. What is this n omega 0 capital T? And omega 0 t is what? What is it? Is equal to 2 pi, isn't it? That's how we defined omega 0. So therefore, this is equal to sine n omega 0 t plus n 2 pi. So what did we say? When you add something n 2 pi to this, is always equal to how else can you see that? Sine of this times cosine of that. What is cosine of n 2 pi? What is cosine of n 2 pi? 2n pi. Come on. Cosine of 2 pi is what? 1. Cosine of 2n pi. 1 again, right? And the other one would be cosine n w0 and sine of n 2 pi. What is sine of n 2 pi? 0. Okay? So sine A plus B is sine A cosine B plus cosine A sine B. So sine of this times cosine of that is equal to this. And cosine of this plus sine of that is 0, so it's equal to that. Okay? That's algebraically how we discover it, but from periodicity, that's how we see it. The same thing is true for cosine and omega 0 t. So therefore, this right-hand side is periodic with the same period as the left-hand side. So they are periodic with period capital T. So how do we determine A0 and B0 and B0? There is no B0 because sine of 0 is 0, so there is no such contribution. So what, can you tell me how we can determine these? How can you find A0, for example? What is integral of cosine x here in one period? If I integrate this, what do I get? 0, right? What if I integrate 2 cosine omega 0 t? What is the integral? It just does this twice, isn't it? So it is 0 and 0. 3 times, 4 times, it doesn't matter, okay? So integral of, so minus t over 2 over plus t over 2 sine n omega 0 t dt is 0 for any n, right? For all n. greater than 0. For n equal to 0, it's not 0. Okay? What else do we know? How about integral of sine okay. What do we say about these things? Let's compute them, right? We know this is 0, right? Let's see when it's so easy to do, let's just do it. Okay, this is equal to what is the integral of this? We are taking, this is 1 over n omega 0 cosine n omega 0 t, and I have to have a minus here because derivative of cosine is minus sine, right? So from minus t over 2 to plus t over 2. Okay? At t over 2, what is this? N, so minus 1 over n omega 0, t over 2 cosine n omega 0 t over 2, okay? And minus cosine n omega 0 minus t over 2. What can you tell me about cosine A and cosine minus A? Same, right? So cosine minus x is the same as cosine x. It is, with respect to, it is symmetric. So the value here is the same as value here. So it is always equal. So this gives you 0, right? So in one period, if you integrate this sine n omega 0 t, you get 0. This, again, 1 over n omega 0, what is this? Sine n. So 1 over n omega 0, this is then what? Sine t over 2 sine n omega 0 t over 2 minus sine. So what is this? Omega 0 t was equal to 2 pi, isn't it? So what is omega 0 t? This is equal to pi. So what is n pi? So sine n pi is equal to 0. This is the same as, so there's a minus here. So it is, this is equal to 0, this is equal to 0. So therefore, that integral is also 0. Okay? So this is also 0. So when you integrate sine or cosine in a period, its integral is equal to 0. How about this? Let's talk about this one. For that, we need to remember a formula. So sine A plus B is equal to sine A cosine B. Last week we did that. And cosine A sine B. And if this is minus, this is minus. So from here, so let me just, A minus B is equal to sine A cosine B minus cosine A sine b. Okay, let me just make. So if you add them together, you get sine a. This time, this side is, okay, 2 sine a cosine b. This cancels, and the other side becomes sine a plus b plus sine a minus b. Okay? So we use this. Then what is that integral equal to? This integral. So minus t over 2 to plus t over 2 sine n omega 0 t cosine m omega 0 t. N and m are constant number dt. That's equal to integral from minus t over 2 to plus t over 2. And this is going to be sine of, you add these two things, right? Sine n plus m omega 0 t plus sine of n minus m omega 0 t dt. Again, we came to the first case, isn't it? You have integral of this, call this L, and call this what? K, right? Some constant times omega 0 t. You are taking integral in a period. So what is this integral? 0. And this, 0. Why? It is the same as this one. Okay? It doesn't matter you call it n or k or whatever. So this integral will be 0. And same thing here. These are called orthogonal basis functions. So in linear algebra, we told you about orthogonal vectors. Okay? These are also vectors. But the inner product here is defined through this integral. So inner product of these two basis functions is calculated in this integral in this time. This is how the inner product in this case is defined. It's an infinite dimensional vector space with infinitely many linearly independent vectors. And what are these? Sine x, sine omega 0x, sine omega 0 t, sine 2 omega 0 t, etc. Right? And the cosines, etc. So how do we now calculate? So I have f t plus capital T is equal to ft for all t. And I want to find ft is equal to a0 plus n equal from 1 to infinity a1 cosine n omega 0 t plus b1 sine n omega 0 t. I want to find what is a0, an, and bn. So I would like to find this. We made all the preparations. Now it's just one line to finish it, right? First of all, I calculate the integral of both sides. So integral of t over 2 ft dt is equal to integral from minus t over 2 to plus t over 2 a0 dt plus integral of So I just take this. Okay, this summation is for both of them. I take the integral of both sides. Okay, this is something we need to calculate. How about this? What is the value of this? This is a constant, right? A0 is a constant we are trying to find out. This from minus t over 2 to plus What is this? T A0. So A0 T. Okay, here I will do the following. I will just interchange integral and summation. Okay? So you have n equal from 1 to infinity a n. I'm sorry. Why do I write 1? A n integral from minus t over 2 to plus t over 2 cosine n omega 0 t dt, and the other one n equal from 1 to infinity bn integral from minus t over 2 to plus t over 2 sine n. What is this integral equal to for all n? 0, right? This is 0. This? It's there. We computed them. This and that is 0. So what is A0? A0 is equal to 1 over t minus t over 2 What can we say about this? So you have an f of t, let's say, something like this, okay? You are calculating this integral and dividing it with the length of the interval. What do we call this value? Who said average? Yes, it's average. It's average. It's average of the function in that period, okay? Good. What's your name? Aybüke. Aferin Aybüke. Okay? So, let's calculate an, okay? What should I do now? I cannot just integrate it again. The trick is done. So what I will do is that I will multiply with cosine m n omega 0 t, okay? So I have f of x is equal to a0 plus n equal from 1 to infinity a n cosine n omega 0 t plus n equal from 1 to infinity b n sine n omega 0 t, right? So what I will do is that I will multiply both sides with cosine m omega 0 t, both sides. And then do what? Integrate over t. So when I multiply that, this is what happens. F of x cosine m omega 0 t dt from minus t over 2 to plus t over 2. I don't like this. It's just, it doesn't clean very well. Okay? That's equal to a0, so integral minus t over 2 to plus t over 2, a0 cosine m omega 0 t dt plus integral minus t over 2 to plus t over 2 n equal from 1 to infinity a n cosine n omega 0 t times cosine n m omega 0 t dt, and the other term is okay. So we have this. So we multiplied basically with we took this, multiplied with cosine m, not n, cosine m just any integer, m omega 0 t, and then we integrate it over a period, okay? We don't know what's the value of this, but let's look at this. What is the value of this integral? Huh? What is it? What? 0. Why? Because a0 is just constant, right? So when you integrate this function over a period, it is 0. For any value of n, it is 0. How about this? So what we will do is that we will, let me just take this term and interchange the integral and the summation. So you have here, let me blow it up. So n equal from 1 to infinity, an integral from minus t over 2 to plus t over 2 cosine n omega 0 t cosine n m okay. What is the value of this integral? It is not 0 always, okay? So we need to look into this. So I didn't do all of them because you would say he's just talking about math. So let me just do that very easily here. So when you have cosine A, cosine B, what is the value of this? So this is how you do that. Cosine A plus B is equal to cosine A, cosine B minus sine A, sine B, and cosine A minus B is equal to cosine A, cosine B plus sine A, sine B. So when you add these up, so you have cosine A plus B plus cosine A minus B is equal to, so this will cancel. You will have 2 times cosine A, cosine B. So you divide this here. So 1/2 this gives you that. Let me continue that integral here then. So what is that equal to? Can you tell me? Somebody tell me that. What will the value of that integral? This one. Okay, so that's equal to n equal from 1 to infinity an integral from minus t over 2 to plus t over 2. So you will have cosine, okay, n plus m omega 0 t, right? This is 1/2 here. Please, what is the other one? IBK, what is the other one now? This term. This is cosine n minus m omega 0 t, right? dt. So that term is this. Who didn't understand this? Please, raise your hand. Everybody understood it, right? Okay. What is the value of this integral for any n and m being positive? This integral will give us, you separate this, of course, into 2 integrals, right? I'm just passing. This is equal to 0. How about this? This will be 0 unless n is equal to m, right? If n is equal to m, so if n is equal to m, then this becomes 1. An integral of it will be, so integral of t. Very good. Who said that? What's your name? Serkan. Serkan. Aferin Serkan. Okay? So if n is equal to m, meaning out of these infinitely many terms, only for one of them, this will be non-zero, isn't it? And that is equal to the m. M, you picked m. M is the value you picked here, right? Okay? It is non-zero. So this is, if n is different from m, this is also 0. This is always 0, and this is 0 unless n is equal to m. Okay? And when n is equal to n, this is t. So that takes care of that. So this first part of the integral then in that case, so this is equal to, what can I say? This is equal to, we said this is equal to 0, right? This is equal to 0. This is equal to am times t. We just discovered that. How about this one? This will be 0. Why? You will have, it's there. Okay? This will be always 0. Okay? So this is equal to 0. But please do the exercise at home. So what did we find out? We found out that an times t is equal to integral from minus t over 2 to plus t over 2 f of t cosine m omega 0 t dt. In other words, or let's make it an, 1 over t from minus t over 2 to plus t over 2 ft cosine m omega 0 t dt. Okay? So what do I do next? I want to find bn's. So what do I do? Multiply by sine omega 0, right? This is how scientists think, okay? What was your name, my old student? Okay. Okay. So you learn from your experience, right? So when you multiply with the coefficient of A0, you are able to solve this. It kills everything else. And to find out that, so let's do that also. So we will take this, okay, equal to A0 plus and plus so as Okan said, I'm going to multiply this with sine m omega 0 t and integrate it. Both sides, isn't it? So you get it, okay? So, again, what happens to this? This integral, the first part, A0, right? This is A0 sine m omega 0 t dt. Integrated over a period, this becomes 0, right? How about cosine omega 0, sine omega 0? It's 0, we calculated that. So here you have sine and sine. So this gives you what? Again, using the same thing, in this case, you will say this or this minus this, right? So you say that, so this is, you subtract this from this, then what do you get? Cosine A minus B minus cosine A plus B is equal to twice sine A sine b. Okay, you divide it. Yes. Yes. What happened to that? Right? That is, we made, what 1 over 2? This 1 over 2, right? We should have it there. So therefore, this is 2 over t. So for A0, it is 1 over t for, absolutely. Good. Okay. So that 1 over 2 is there. Okay. So using that, what is this integral now? Please tell me. So this integral now is equal to, let's write it here. So that's equal to minus, so 1/2 sine, or this is cosine, so a minus b. So this is n minus m omega 0 t minus cosine n plus m omega 0 t dt. So what is the value of this integral? 0, because n and m are positive, so they can never. So this is, the contribution of this is 0. How about this? This is equal to, if n is equal to m, this is equal to t. But with this one, t over 2, right? Otherwise, it is 0. 0 otherwise. So therefore, what do we have now then? So this, okay. So I have integral from minus 2 over 2 to plus 2 over 2 f of x sine m omega 0 t dt is equal to, so what is the contribution of the first one? 0, zilch, right? Second one, no contribution. Third one, bn, right? And what was that? T over 2. So what is bn? 2 over t minus f, what is x? f of t sine n omega . So let me write the other ones here for ease of remembering. A0 is special. It is 1 over t. So this is how you can represent a bunch of any periodic function with some mild conditions attached to them with a Fourier series. And of course, Fourier series, let me write it here. F of t is equal to A0 plus n equal from 1 to infinity an cosine n omega 0 t plus bn sine n omega 0 t. Okay? This is the Fourier series. So you take any periodic function, okay, then it can be represented in terms of sines and cosines. What is this? Isn't this analyzing your signal? You have a periodic signal, okay? By doing this decomposition, you are finding out how much of which frequency you have in your signal, isn't it? It is giving you exactly which frequencies do you have. Of course, this omega 0, who defines omega 0? Do I define it? Who defines it? How is it defined? How do we know omega 0? It is the period of the function, isn't it? So the function is periodic with period t, capital T, right? So it tells you omega 0 is equal to 2 pi over t. So you know the periodicity of the signal defines your fundamental frequency. What else is it telling us? What it's telling us is that you have the fundamental frequency and its harmonics. What is harmonics? Harmonics is the multiple of those frequencies, okay? So if you have, for example, omega 0, you do not have omega 0 times 1/2, okay? Or 3.1 times omega 0. What we have is, it's just omega 0, 2 omega 0, 3 omega 0, 4 omega 0, etc. So it is not a continuous spectrum, okay? So we'll talk about, hopefully next week or the week after, we'll talk about continuous spectrum as well, okay? So periodic signals have this property that it has only a fundamental frequency and it is harmonics. Isn't this beautiful? That how nicely you can represent any periodic signal in terms of sines and cosines. Okay? Let's do an example. Example 1. Example 1 is that you have delta t and you have so it is, this periodic function is that it's a delta function, okay? So it repeats after. What is the length of the period? It is capital T, right? So what is A0? A0 is from minus T over 2 to plus T over 2. Let's apply the definition. F of T dt, right? So this is 1 over T here as well. So what is this now? 1 over T minus T over 2 to plus T over 2. F of T is delta T dt. What is this value of this integral? 1. So this is 1 over T. Okay, let's calculate AN. So what is AN? So it is 2 over T minus cosine n omega 0 T dt. What is this equal to? So, what is it? So this is equal to, just calculated this at t equal to 0. This is 1, okay? So that is 2 over t times, this integral is, the length is t, right? So it is is 2. Did I make a mistake here? No. Right. We have it here, right? 2 over t. We are integrating over the integral period. So this is t equal to 0. This is 1. This is 1, not t, right? This is 1. So 2 over t. Okay, Bn. What is Bn? 2 over t, integral from minus, what is it? Delta t sine n omega 0 t dt. What is this equal to? This is 1 and multiply with the value of this at t equal to 0. What is that? 0. So what is the Fourier series of delta function, it is 1 over t plus 2 over t times n equal from 1 to infinity cosine n omega 0 t. And signs are all 0. What does this tell you? What this is telling you is that all frequencies are equally important in this signal. So it has omega 0, 2 omega 0, 3 omega 0, 4 omega 0. All of them have the same Fourier coefficient. So it never dies down. So this means it's an impossible signal, right? It has all of the frequencies are there, and they are all equally important in this spectrum. So it never dies down, okay? It's like white noise. It's not white noise, of course. It's not a continuous spectrum, but it has all of the harmonics existing there, okay? Any question on this? This is the simplest example you could have because integrals are very easy to calculate, okay? Okay, example 2. Let's take f of x defined with this graph here, f of t, okay, t. So it is so this is one period. Okay. This is 1, this is -1. Okay. Let's calculate A0. IBK, what is A0? Zero. Why? Because the integral of this function, right? This is f of x. Integral of this function divided by the length of the integral is 0. This is equal to that, okay? Who understood this? Any problem with this? A0 is 0, okay? AN. What is AN? 2 over t minus, from minus t over to plus t over t, then what is this? F of x cosine n omega 0 f of t. Why am I saying dt? Okay. So how do I go about this? I will separate it into two integrals, isn't it? This part and that part, since it is a discontinuous function. So I will write 2 over t from minus t over 2 to 0. What is the value of the function there? -1. So it's -1 times cosine n omega 0 t dt plus from 0 to t over 2. What is the value of the function here? 1 times cosine n omega 0 t dt. Let's make a change of variable here. Let's replace t with minus x. Okay? If we make change of variable, dummy variable, so this dt is equal to minus dx. So this is what happens to this integral here. 2 over t. This lower limit becomes 2 over 2. 0 becomes 0. -1 cosine n omega 0 minus x. Okay, and this dt is minus dx. And what is that equal to? This minus and minus goes away. This minus doesn't matter because it's inside cosine, right? And this becomes, if you switch it from minus 2 over t, 0 to 2 cosine n omega 0 x dx. So what happened? This, of course, I have here plus 2 over t. So this and this cancel each other, isn't it? This is minus of that. So there is no an. All an's are 0. Okay? How about bn? Of course, bn cannot be 0 too, right? We have to have something non-zero. The function is not 0. So that's equal to minus t over 2 to plus t over 2 f of t sine n omega 0 t dt. Again, we know the drill now. 2 over t minus t over 2 to plus t over 2. This is minus 1 sine n omega 0 t dt plus 2 over t from 0 to, and this is 1 times sine n omega 0 t dt. We make change of variable here again, right? We say t is equal to minus x, dt is equal to minus dx. If you apply it here, what do you get? 2 over t. The lower limit becomes, in terms of x, it becomes t over 2. This is 0 minus 1 times sine n omega 0 minus x. And this is minus dx. Now this, what is this sine minus something? What happens to that minus? It comes out, right? So you have one minus here, one minus coming off here, and one other here, right? So the result is, and you also flip this, this becomes 2 over t, 0 to 2 over 2 sine n omega 0 x dx. It is the same as that one, so that becomes 4 over t, right? Everybody following? I don't allow phones during the lecture. Please, everybody, turn off your phone or just put it aside, okay? So what is this now? 4 over t. What is the integral of that? Come on, all of you know this. Please respond. What is this equal to? Integral of sine omega n omega 0 x. 1 over n omega 0 cosine n omega 0 x. Of course, you have to have here minus 1, right? From 0 to t over 2. So what is that equal to? In the upper limit, 4 over, so minus 4 over t n omega 0. What is t omega 0, by the way? T omega 0 is equal to what? Remember that? 2 pi. Very good. So 2 pi n, and this cancels with this, so 2 over pi n. Very good. Times. So you have, in the upper limit it is, so this, you have a minus here. Cosine, what is that? Cosine n omega 0 t over 2. Minus, in the lower limit it is cosine of 0, 1. So what is this? Omega 0, 2 is, so let me just continue here, minus 2 over pi n times. This is 2 pi over 2, so this part is cosine n pi minus 1. Okay, what is this now? Cosine n pi. So for n 1, 2, 3, etc. This is for n equal to 1, it is minus 1. For n equal to 2, it is 1. So this is equal to minus 2 over pi n minus 1 to the n minus 1. Okay? So in other words, let me write it like this. So it is 2 over pi n times 1 minus 1 to the n. Okay? Let me write it here. So this is an turned out to be 2 over pi n 1 minus 1 to the power n. If you write it as a sequence, so this first term is for 2 over pi. For n equal to 1, this is minus 1, so this is 2, right? For n equal to 1, this is minus 1 to the power 1 is minus 1. 1 minus 1 is 2. So that's 4 over pi. Next term, for n equal to 2, this is 0. Okay? For n equal to 3, this is again, for n equal to 3, this is minus 1. 1 minus 1 is 2. So this is 4 over 3 pi. Right? Then next one, for 4, this is 0 again. For 5, it is 2 again. So this is. So just take this 4 over pi out. So you have 1 plus 1 over 3 plus 1 over 5, 1 over 7, etc. Right? This is how an why am I adding that? What I meant is this is okay. It is like this: 4 over. It is okay. Just simple. So what is this general term? Is equal to 1 over 2n plus 1. And we have 4 over pi, right? So an is equal to a 2n plus 1 is equal to this. That took care of it. This is what it is. So it is 0 for others. So a 2n is 0. You are right. We should write it. Okay? We are doing it together. Okay? Yes, I am also enjoying solving it together with you. Okay? So when I make this small mistake, that's just we are discovering it. I'm not putting slides here for you to watch. We are doing it together. Okay? So what is the Fourier series then? For this f of t is equal to, this is A or B? This is B, right? B and B. A was 0. Huh? An is 0. So there is no an. So f of t is equal to n equal from 1 to infinity 4 over pi 1 over 2n plus 1 sine 2n plus 1 omega 0 t. So that is the Fourier series. So here you have only have omega 0, 3 omega 0, 5 omega 0, etc. And it's not dying very quickly. It's not dying down very quickly, but it is dying down. Okay, as it goes to infinity, this goes to 0. It goes to 0 slowly. Okay. Let me give a 10-minute break. Then I will tell you more interesting things. Now, we talked about Fourier series expansion of periodic functions. So we said that, everybody please put away your phones now. The lecture started. So if you have f of t is equal to f for all t, such a function is called periodic. Okay? under some mild conditions, you can represent this, we said, with Fourier series. Now, I will tell you about complex Fourier series. Last week, we did the review and we said that e to the I theta is equal to cosine theta plus I sine theta. Okay? Now, let's consider e to the, okay, in electrical engineering we use j omega 0 n omega 0 t, n omega 0 t. Is this periodic? It is, right? First of all, it is periodic because it's just cosine n omega 0 t plus sine omega. But we can just also very easily say that, okay, is this equal to e to the j n omega 0 t plus t. Is it? So how can I write this? This is equal to e to the j n omega 0 t times e to the j n omega 0 capital T. What is this equal to? 2 pi. So this is e to the j n 2 pi. So what is it equal to? E to the j n 2 pi. What is that equal to? Cosine n 2 pi plus I sine n 2 pi, which is equal to 1. So therefore, this is equal to e to the j n omega 0 t. Right? So in electrical engineering, we use j. I like I more, but in electrical engineering, we use I for current. So therefore, it's a tradition that in electrical engineering, these complex variables, j is equal to square root of minus 1. That's the convention we use. That's in mathematics, we use I for that. Okay, so therefore here we prove very easily that it's easier than proving even there that e to the j and omega 0 t is periodic with capital T, right? Okay. Then we ask the following question: can I represent ft with this? Cn e to the j n omega 0 t. Okay, very simple. Okay. The answer is yes. So how do you find Cn? So what are Cn's? And what is the relationship between this and that? Okay, this is what we will discover now in the next 10 minutes. Okay. Now let's think like a scientist. My old students, how would you approach this problem from your experience? How would you approach it? My new students, how do you approach this? So what should I do now? It's very similar to what we did there. What is my basis function here? Is it cosine or sine, or what is it? It is now e to the j n omega 0 t, right? So we multiply, yes, we multiply both sides with, let's say, k omega 0 t, okay? And the other side also ik, jk, j n omega 0 t times, okay, e to the minus j k omega 0 t. And I integrate it over a period. So simple. Okay? So here, there is nothing to do. Let's see what can we do here. So it's clear, right? I multiply both sides with the same thing, and I integrate. So when you multiply both sides of the equality with a non-zero something, the equality doesn't change, right? So then you integrate them over the same period. So equality is still preserved. So here, let's just interchange summation and integral. So what do you have? So n comes out, n equal from 0 to infinity, Cn minus 2 over 2 to plus 2 over 2, e to the j n minus k omega 0 t dt. Okay? Now let's look at this integral from your experience from last class, just one last hour. Okay, what is this equal to? No, we don't need to do that. Okay? Okay, let's calculate this integral now. E to the, so integral from minus So this is integral with respect to t. So it is e to the at. What is the integral of this? You remember that? So 1 over j n minus k omega 0 t, provided n is different from k, right? And this is e to the j n minus k omega 0 t. If n is equal to k, then what is this? If n is equal to k, this is e to the 0. So it is 1. So what is this integral equal to? T. There is no t here, of course. J n minus k omega 0. So this is from minus t over 2 to plus t over 2. Okay? So what is this? In the upper limit, what is the value of this? E to the j n minus k omega 0 t over 2 minus e to the j n minus k omega 0 minus t over 2. Okay? What is omega 0 t? 2 pi. So this is divided by, so this is pi. So what is this e to the j n minus k pi? This is equal to? Minus 1 or 1, okay? So it is n e to the j n minus k pi. And this is e to the j n minus k. This is minus pi. So does it make any difference? It is plus or minus here. Sign of it is already 0, right? Think of that. So it is minus or plus, doesn't matter. So this is equal to 0. Again, the same trick. So this integral, the whole thing boils down to what? From minus t over 2 to plus t over 2, f of t e to the minus j k omega 0 t dt is equal to t times c k, okay? Or ck is equal to 1 over t minus t over 2 to plus t over 2 f of t e to the minus j k omega 0 t dt. It is so much easier, isn't it? When you go to complex domain, everything just was taken care of in one go, right? There we have to calculate an and bn and so many cross multiplications of cosines and sines and everything. Here, it is so easy. But are they the same thing? What does this tell me about the other thing? What are they talking about? How different are they? Are they related? Which one should I use? Okay, any question on how we obtain this one? Who understood it? 1, 2, 3. The rest didn't understand. Who did not understand it? Did you understand it? No. Okay, where did you get stuck? Yes.
I mean, I understand all the equations, but something is missing, but I don't know
what is missing. Okay, let me repeat this. What we are saying is that e to the j omega 0 t is periodic, okay? With period t. Do we agree on this one? Do you understand this one? This periodicity, right? What does it mean? That means e to the j omega 0 t plus capital T is equal to e to the j omega 0 t e to the j omega 0 capital T. Omega 0 capital T is equal to 2 pi, okay? Omega 0 is equal to 2 pi over T. We discovered that in the first few minutes of the class, okay? So therefore, this is equal to e to the j omega 0 t. Okay, so we established that like cosine omega 0 t and sine omega 0 t, e to the j omega 0 t is also periodic with the same period, okay? As a matter of fact, this is just equal to cosine omega 0 t plus j sine omega 0 t. So what we are saying is that, okay, what we did last class is we showed that we can represent any periodic function with period capital T in terms of sine omega 0 t, cosine omega 0 t, and their harmonics, right? What we are saying here is similar thing. Can I do the same thing for this basis function? Meaning, can I take e to the j n omega 0 t, okay? And take all of these from minus infinity to plus infinity, okay? Cn such that this is equal to my ft, ft being a periodic function. For all t, right? For all t is very important. If this is satisfied for one t, you cannot say it's periodic. It has to be true for all t. Okay? So the question is this. Now the rest is just trick. How do you obtain those CNs, right? We said, let's multiply both sides with this basis function, the minus of the basis, complex conjugate of this basis function. What is complex conjugate in general? If you have a complex number and you see j there or I, you just replace every j or I with minus or minus j. It doesn't matter if it is an exponent or an addition or wherever it is, okay? Wherever you see it, you just replace it with minus of it. It will give you the complex conjugate. Okay? So what we said is that let's multiply. So we have this. Let's multiply both sides with e to the minus j k omega 0 t, okay? Any problem with this? Does it break equality? No problem, right? Since these are equal, their integral also should be equal. Okay. As you see, this summation is over n. So this is just a constant. As far as this integral or the summation is concerned, this just has no effect on it, right? So what I did here is, like, I don't even need to put this parentheses here. Just interchange the summation and integral, okay? This has nothing, this is no dependence on t, so the integral can move up to here. So therefore, this is equal to minus t over 2 to plus t over 2. So here, summation n equal from minus infinity to plus infinity, Cn times, okay, e to the j n omega 0 t okay, and this is equal to Cn integral just bring them under common. Now you look at this one. Okay, this is what is the value of this integral? When n is equal to k, if n is equal to k, this integral is equal to, n equal to k means we are just talking about just one term here. So that's equal to ck, and this is 0, e to the 0 is 1, minus t over 2 to plus t over 2, integral of 1 is t, right? So this is equal to t, ck. This is the value. For n different from k, there are infinitely many terms, right? As a matter of fact, double-sided infinite. It's minus infinity to plus infinity, right? So cardinality is. So here, when n is different from k, what is the value of this integral? It's just exponential. So integral from minus t over 2 to plus t over 2 e to the j n minus k omega 0 t dt is equal to 1 over, please tell me, j n minus k omega 0 e to the j n minus k omega 0 t minus t over. Now we look at this one. In the upper limit, what is it? So e to the j n minus k omega 0 t over 2. What is this? Omega 0 t is 2 pi. Over 2 is, this is pi now, right? And this is equal to e to the j n minus k omega 0 minus t over 2. Okay? So this is e to the 1 over j n minus k omega 0 times e to the j n minus k pi, and this is e to the j n minus k minus pi. Are they different? What is this? Cosine of this plus sine of this. Sine of this is always 0, right? Cosine of this is, whatever it is, it's same as this. Cosine of minus something is equal to cosine of that thing. So this gives you 0. So the whole thing is, then you find out that this is equal to C K times T. Okay? Who understood it now? Okay, the others, what is the problem you have? Somebody is looking at his phone or her phone. Phone is not allowed. Why didn't you understand? What's the problem here? Where did you get stuck?
I didn't attend the class last week, so
But today we started fresh from Fourier series. Please. You are electronics engineer, right? Hopefully you will be. This is very, very, very, very important. Especially this class. Today we are talking about frequency of a signal. Okay, this is the first class that we formally define the frequency and the harmonics and how do you analyze a signal. So this class is a historical class for you. Okay? Okay. Let's see what is the relationship between this and that. Meaning the Fourier series we did in terms of cosines and sines, and the Fourier series we did in terms of this complex function. So how are they related? So let me separate this into three portions, okay? First portion is for n equal to 0, I call that C0. Plus summation from n equal from minus infinity to minus 1, Cn e to the j n omega 0 t, okay? And from n equal from 1 to infinity, Cn e to the j n omega 0 t. Any questions or any objections on this? No problem, right? So let me replace here n with minus n. Can I call this n or this n as dummy variable? So if I replace, or let me call L is equal to minus n. Any problem with that? So what do you have then? C0 plus. This becomes L equal from 1 to infinity, L, right? C minus L, because n is equal to minus L, e to the minus j L omega 0 t plus any problem about this? They are the same thing, right? So this is, if you just, let's write a few terms of this, right? This is, let me just expand this. This is what? The first term is C minus 1, e to the minus j, L is 1, okay, omega 0 t. So it is minus j omega 0 t. The second term, L equal to 2, this is C minus 2. And this is e to the minus j2 omega 0 t, etc. And what is this? C minus 1, e to the minus j omega 0 t, right? For equal to minus, C equal to minus 2, it is C minus 2 e to the j, right? Minus 2 j omega 0 t. It's the same thing, okay? It's dummy variable, right? If you have any problem with it, please, let's clarify it. This is not even trivial. This is even less than trivial, right? Okay. So can I call this again n, if you don't mind? Any objections? Can I just bring them under the same same summation? Any objections? These are very simple, trivial steps. But it's possible that you don't understand it. Please ask, because it's just, I'm just playing with indexes, that's all. Okay? So now let me expand these. Let me write those here. What is e to the minus j n omega 0 t? This is cosine n omega 0 t minus j sine n omega 0 t. And e to the j n omega 0 t is equal to, obviously, okay? So I will just multiply these things here, okay? So c minus n times e to the j minus j n omega 0 t is equal to c minus n cosine n omega 0 t plus minus j sine n omega 0 t, and c n e to the j n omega 0 t is equal to c n cosine n omega 0 t plus j sine n omega 0 t. So we will add these, right? Let's add them and let's just collect them together in one thing. So what is the coefficient of c n omega 0 t? What is it? C minus n plus Cn. Isn't it? If I add these together, I have cosine n omega 0 t here and there. One of them is multiplied by c minus n. The other one is multiplied by Cn. So you take, this is not c, this is cosine, okay? This is cosine n omega 0 t. And what is the coefficient of sine n omega 0 t? What is this? Minus j Cn plus j c minus Cn. Okay, so you can just take this out. Cn minus Cn minus c minus n. Okay? So what do I have? Ft is equal to C0 plus n equal from 1 to infinity c minus n plus Cn cosine n omega 0 t plus n equal from 1 to infinity j times Cn minus c minus n sine n omega 0 t. Okay, what was the other one? The other one was Ft is equal to, this was A0 plus n equal from 1 to infinity An cosine n omega 0 t plus n equal from 1 to infinity Bn sine n omega 0 t. So, what is it? What is An in terms of Cn? So what is A0? IBK, what is A0? Just, isn't it the same thing? You have, isn't this also Fourier series expansion, you have cosine and sines, right? So we are just comparing this. So A0 is equal to C0. What is AN? Huh? Okan, what is AN? Cn, C minus N plus Cn. What is Bn? Serkan, J, Cn minus C minus N. That's it. How about the other way around? If I was given the Fourier series in the classical sense, okay, not the complex one, how could I obtain my complex expansion without actually doing it again, all over again? So you have AN is equal to C minus N plus Cn, and Bn is equal to J Cn minus C minus N, right? So let's solve for Cn, for example. Okay? Or let's solve for C minus N, it's easier. Okay, so from here you obtain B over J is equal to Cn minus C minus N. And the other one is AN is equal, this is Bn. AN is equal to C minus N plus Cn. So from here, what do you have? You just add them together. This will cancel. 2Cn is equal to AN. And how can you write this? Bn over J. Minus J Bn. Right? Cn is equal to this. Then what is C minus N? C minus N is just equal to, but then anyway, just that's it, Cn, that's all we need. Cn is this, right? That's it. So if you have one kind of Fourier series, the other one is just this simple relationship. So they are equivalent. Therefore, we mostly use the complex Fourier transform now. Okay? It is much more straightforward. The formulas are more clean and everything. Okay? And it also translates into Fourier transform and Laplace transform and everything. So there is a unified way of looking at it. Let me do one example on this one as well. Let's repeat the same question that we did for the Fourier transform. Any question, please? So you can all obtain this relationship, right? No problem. So Ft was defined with this graphics. So just continues like this, right? So this is one period. The width of the period is capital T. Okay. So I want to calculate Cn. Cn is equal to minus T over 2. And what was here? I have here 1 over. Did I erase it? 1 over T, right? 1 over T. This Ft e to the minus j n omega 0 t, where omega 0 is equal to 2 pi over t. Okay. So what is this equal to? 1 over 2, 1 over t. So I have to divide this into two pieces because the function is a discontinuous function. So if I had 5 sections like this, then I would have to divide it into 5 sections, isn't it? So you have to just treat each section separately if it is a discontinuous function like this. Okay? So it is from minus t over 2 to 0, it is minus 1 times e to the j n omega 0 t dt, plus from 0 to t over 2, the function there is 1 e to the minus j n omega 0 t dt. And this function, integral of this function is what? Minus 1 over, what is this? What is the integral? This integral. E to the AT. What is the integral of e to the AT? 1 over minus j n omega 0, right? E to the minus j n omega 0 t for minus 2 over 2 to 0. Okay. Plus 1 over minus j n omega 0 e to the minus j n omega 0 t 0 to t over 2. Okay, so this 1 over t is common. Let me just start here. So this is 1 over, so this minus and minus goes away, 1 over t, 1 over j and omega 0 t. What is this? Omega 0 capital T is what? 2 pi. You look like very tired. No response. Okay? And this is what? J and omega 0. Okay, this is, in the upper limit, this is e to the 0 is 1. In the lower limit, it is minus e to the j n omega 0 t over 2. What is that? This is 2 pi divided by, so this is pi, right? It looks familiar, doesn't it? So this is 1 minus 1 to the power n. And this one, e to the minus j n omega 0 t over 2 minus 1. What is this again? This is pi. So it is e to the minus j n pi, right? So we have to have a minus somewhere here. So there's a minus here, right? This is minus.
First integral is minus. Is missing.
Is what?
The first integral minus is missing.
Minus is not missing because
Below this one. Below.
this and this canceled each other. There was a minus coming from the function itself.
When we integrate this,
When we integrate this,
we
we switch them.
extra minus.
Did we add extra minus? This is from upper limit. This,
İkinci de şey oldu da eksi 1 orada fazla geldi.
what is he talking about? We both don't understand. Tell us in Albanian. Okay, let me erase this. Let's start again. Okay, no need to argue. Okay. So we are talking about this, right? So 1 over t. So let me take this minus also here. So minus 1 over t minus t over 2 to 0. E to the minus j n omega 0 t dt. So this is equal to minus 1 over t. Okay, this is this. Well, divide this now. Minus j n omega 0, right? This is the exponent. Now e to the minus j n omega 0 t from minus t over 2 to 0. Okay? So this and this cancel. So therefore you have 1 over, so this t and omega 0 makes 2 pi, right? So this is 1 over j and 2 pi, right? So there was no mistake. Anyway, no problem. So in the upper limit, this is 1. In the lower limit, this is minus e to the minus j and omega 0 minus 2. Were you talking about this minus? It doesn't matter. Yeah, that minus, it doesn't affect the result. So this is equal to minus pi, and this becomes plus pi. So it is equal to 1 over j and 2 pi, 1 minus e to the j and pi. Okay, so this is 1 minus 1 to the n divided by j and 2 pi. Okay. Let's now talk about this one. Let me try to do that here. So integral from, I will just leave this aside. Let's just talk about this. From 0 to t over 2. Any problems? Any questions? Are everybody following? Good. E to the minus j n omega 0 t dt is equal to 1 over minus j n omega 0. E to the minus j n omega 0 t from 0 to t over 2. So this is 1 over minus j n omega 0 times e to the minus j n omega 0 t over 2 minus 1. So this is pi. So this is minus 1 over j n omega 0 minus 1 to the power n minus 1. Okay? And you have one over t. Let's add that here. So that is minus 1 over j and 2 pi. Minus 1 to the power n minus 1. So this is 1 minus. So they are the same, isn't it? So the result is, you just take this out. So Cn is equal to, so Cn is equal to 1 plus minus 1 to the n divided by j and pi. So in other words, C to n is equal to this might 1 minus C to n is equal to 0. Do you agree? C to n plus 1 is equal to 1 minus so that's equal to 2. Of course, C0 is also 0. Why? Because the symmetric in average is 0, like we found before, right? I will stop here because I see that everybody is totally consumed. After next week, we will have our first quiz, okay? So next week, I will continue a little bit more on this. I will talk about Parseval's theorem. I will finish it. And I will do some more examples on this. So we will solidify this. So make sure that you are in this class 5 minutes before the class starts, okay? I will review and do new things on on Fourier series representation of signals. I will see you next week.